We're going to review some common factoring techniques that will help you in this unit because you'll be doing a lot of factoring in this unit. The first one is, to remind you, is to just factor out a common factor. The second one is the difference of two squares. And we're going to look at an example that has both of those things in it, and then we'll move on to something else. So anytime you see a common factor, that's good to start with. So if I have a polynomial that looks like this, f of x equals 3x to the fifth minus 48x. And I know that this is going to have 5 zeros, and I want to try to find the 5 zeros. So the first thing I can do is notice that x goes into both of those, and it turns out 3 does too. I can factor out a 3x. This would give me x to the fourth minus 16. Now I notice that I have a difference of two squares, x to the fourth minus 16. They're both perfect squares. And that means I can factor this into two factors. I have an x to the fourth, so this has to be an x squared and an x squared to give me the x to the fourth. And to get the negative 16, I have a positive 4 and a negative 4. Notice the middle term cancels out, so that's why it's called a difference of two squares. You have the same number here and here, but when you multiply this out, you'd have a positive 4x squared and a negative 4x squared, so that term would cancel out. Now notice this also gives me another difference of two squares, which is x squared minus 4, so this is 3x times x, oops, don't know where the 3 came from there, x squared plus 4 times x plus 2 times x minus 2. So that's another difference of two squares. Now I can find all 5 zeros now. Looking at this factor, I would have x equals 0. That would make the whole thing equal to 0. Looking at this, we did this before. If I set this equal to 0, x squared plus 4 equals 0, x squared equals negative 4. I'm going to get plus or minus 2i. For the zeros that go here, this would be a 0 of negative 2, and this would be 0 of positive 2. So I was able to factor this fifth degree polynomial and find all of the zeros. So sometimes that's a possible way to find the zeros. Okay, secondly, this is kind of a typical, just factoring something in that's a quadratic. So I have this quadratic equation, 6x squared plus 11x minus 10. And I purposely picked one that wasn't as obvious. So what I need to do is to factor this into two factors. Now I'm going to put a couple of possibilities because this is trial and error. Either this is a 6x and an x, or this is a 3x and a 2x. So those are my only two possibilities to get the 6x squared for my first term. Then I'm going to look at my last term. My last term is a negative 10. So possibilities for negative 10 are negative 2 times 5, positive 2 times negative 5, positive 1 times a negative 10, or negative 1 times a positive 10. So those are all of the different combinations of numbers I can put them in. Plus I can put them in either order. This could be a 10 and this could be a 1, or vice versa. So this is where there's some playing around involved because I need to get the middle term to end up being 11x. And the middle term comes from multiplying 6x times whatever number I put in the last position, and x times whatever number I put in the second position here. So so let me just kind of do, just off the top of my head, what if this is minus 2 and this is plus 5? Do I get 11 for my middle term? This gives me 30 and this gives me negative 2, so no. I would get 28x. So that wouldn't work. So let me try another one. I could do 10 and 1. So this gives me negative 10x plus 6x, which is negative 4x. If I switch the 10 and the 1, I'd have 60 times and a 1, so that's not going to work. So it looks, and I forgot to switch the other ones, but it doesn't work either. It turns out we have to use the 3 and the 2. So let me put in plus 2 minus 5. This gives me positive 4x and a negative 15x. That's almost what I want because that would be negative 11. So what I really want to do is switch these signs. So then if this was a negative 2 and a positive 5, then this would give me negative 4x. This gives me 15x, and that gives me 11x. So this is the factorization. Now, I don't usually write out as many possibilities. I usually do a lot of that mentally because I'm very practiced at it, but for you, you might have to write out and do a little trial and error to get the factorization. Now, of course, in a quadratic equation that has a simpler form, like maybe you have x squared minus 5x plus 6, you can do this maybe a little more quickly in your head because you know that's x, and I can think, okay, these two numbers have to multiply to give me 6, but then I need to have 5 for a middle term, so you can quickly think -2, -3, and that gives you the -5. That's because this is a 1 here. If this is not a 1, if it's a 6, then there's a little more trial and error. If this has another coefficient that's not 1, because you have to play around with the beginning coefficients as well as the constants to get the middle term. Now, we can also do something with quadratic factoring that you may not have been aware of. You could have something that's in quadratic form. X to the fourth, so here's my polynomial, f of x equals x to the fourth minus 5x squared plus 6. This isn't quadratic, but it is in quadratic form because I have a variable, x squared, and a variable squared. So x to the fourth is the square of x squared. So this is in quadratic form, which means I can factor it just like I did a quadratic, only instead of having x and x, I'm going to have an x squared and an x squared. And notice this is exactly what I just did. I must have been thinking about this example that I did yesterday. -2, -3. So I have x squared minus 2, x squared minus 3 are my two factors. That gives me the -5x squared for my middle term. I can set each of these factors equal to 0. So x squared minus 2 equals 0. X squared minus 3 equals 0. So I have x squared equals 2. X squared equals 3. So I have x is equal to plus or minus square root of 2. X is equal to plus or minus square root of 3. And there are my 4 zeros. One other method I want to talk about is factoring by grouping, and this one is, you don't see this one as often, but occasionally you can find this. I have 3x cubed plus x squared plus 6x plus 2. Now, factoring by grouping works if you have the four terms in your polynomial, and you're able to group them into two smaller kind of subgroups, and each of them, when you factor out a common factor, you end up with the same thing inside the parentheses. And that's the only time it works, is if you end up with the same thing inside the parentheses. So if I factor out here a 3x, I get x squared plus 1. No, sorry. If I factor out a 3x squared, let's try this again. If I factor out a 3, no, I can't factor out a 3 at all. Sorry about that. I can factor out an x squared. Half point, you're all screaming, I know that. 3x plus 1. Here I can factor out a 2 and I get 3x plus 1. So notice I have a common factor of 3x plus 1. So basically what I'm going to do is factor out the common factor, and the common factor here is 3x plus 1. So if I factor out a common factor of 3x plus 1, what I have left over is x squared plus 2. So in other words, x squared plus 2, wish this thing worked a little more fluidly, x squared times 3x plus 1 plus 2 times 3x plus 1, which is what I have right here. Now, and then I could, so that's the factored form, and then I can set each factor equal to 0 and find the zeros. X squared plus 2 equals 0, so 3x equals -1, x equals -1/3. X squared equals -2, so x equals plus or minus the square root of 2i. So this has one real and two imaginary roots. Notice if we looked at our rational, this is just a little plug for the rational root theorem. Remember, it'd be plus or minus 1, plus or minus 2 over plus or minus 1, plus or minus 3. So the possible rational roots would be plus or minus 1, plus or minus 2, plus or minus 1/3, and plus or minus 2/3. And one of the numbers that we got, and the number that we got for our root was -1/3. So that turns out to be a rational root. There are some other factoring patterns, like for example the difference of two cubes. If we have something that's in the form a cubed minus b cubed, we can factor it into a minus b times a squared plus ab plus b squared. If you just remember this part of it, okay, for example, let's say I have x cubed minus 27. Well, my a in this case would be x and my b would be 3. And so I could factor this into x minus 3 times, and if you don't remember the other part, at least you know that it has a 0. One of its zeros is 3, and you could use synthetic division to find the rest of it. But the rest of it would be x squared plus 9x, no, I'm sorry, yeah, x squared plus 3x plus 9. Okay, so that's another. The same thing works for the sum of two cubes, a cubed plus b cubed. So in this case, if we had x cubed plus 27, it would be x plus 3, and then x squared minus 3x plus 9. So that's how you would factor that one. So that's one that doesn't show up as much, but you can factor a sum or difference of two cubes. So that's a really quick review of the major factoring things that you learned in previous classes. Hopefully that'll be helpful.